Okay, because we are going to be using our identities to help us factorize this. Okay, so in case you have forgotten your identities, maybe let's just do a quick recap. Okay, let's focus on the other way around this time around. Okay, a squared plus 2ab plus b squared. What does that equate to? Let's see. Lucas card. Sorry, Lucas K. Sorry. So it changes. I think 0 was the last one. Right? Okay, 0. Can you tell me what does this equate to? Bracket a plus b squared. Excellent. Okay, next one. Okay, KD. KD. Okay, so wait, what does the second formula give us? Okay, bracket a minus b squared, very good. And the last one is square minus b squared. What does that give us? Evan. Francis did do a little bit slower. Okay, what does this give us? Okay, great. Alright, so in this case, x squared minus 4y squared. What should we get then in this case? Let's call out another name. Let's see. Matthias. Okay. Elise. A bit slower. Okay. So x squared minus 4y squared. What will we get when we factorize? Using our identities there. Why are you helping a person from the other team, Hanshan? So it is just a problem about taking answers from someone else, right? You think it's correct in the first place? Yeah, why is it 4y? So what do you think it should be then? Okay, this is what rho is. So which one is correct? Okay, it is. What do you think? The second one. What do all of us think? Thank you, MC. What do we all think? First one or second one? Who says first one? Second one. Okay. So what was the problem here? For this square, the square belongs to what? No, the square only belongs to the y. Okay, so we needed the square for everything, which is actually bracket 2y squared. So actually it should be x plus 2y times x minus 2y, whereby a is given to be x and b is 2y. Okay, so that is our factorization for part 1. Now, let's look at part 2, which is a more challenging question. It says that given that x and y are positive integers, we want to solve x squared minus 4y squared equals to 5. Okay, so since they gave us something similar looking in part 1, alright, maybe we should use part 1 to answer this question. Okay, so when the question asks us to solve, it means that we are trying to find out what is the value of x and also what is the value of y. Okay, so when solving this equation, this is what the question wants us to do. Okay, so given that x squared minus 4y squared equals to 5, and since we have written something in part I regarding x squared minus 4y squared, let's apply it and see what is it that we get. We are going to get x plus 2y times x minus 2y equals to 5. Okay? But even if we get this, so what? Okay? We need to have a better understanding about the number 5 over here. What kind of a number is 5? It's prime number. Okay? We also know that it's the odd number, right? But it is helpful for us to think about it as a prime number. Why? Because of all, 1 and 5, they are actually integers, they are whole numbers. Okay? Question gave this condition that says that given that x and y are positive integers, so you can think about it as your whole numbers, okay, just that 0 is not involved. Okay? If let's say I have two numbers that are positive integers, when I add them up together, will I get a fraction? Is it possible for us to get a fraction? No, right? Okay? I cannot have two whole numbers adding together and suddenly get a fraction, like 2 over 5. Never possible. Okay? Likewise, when I subtract, okay, when I minus two numbers that are integers, that are whole numbers, I will also never ever get fractions. Okay? It will never happen. So I have great certainty that this must be an integer, and this is also an integer. Okay, so I have confidence to say this because of the condition given to us here. If the question did not mention this can be a fraction, this can be a fraction. Then there are many ways for us to get 5. I can have 1 over 5 times 25, give me 5. Okay, so this covers, alright, the basis that we can only look at 1 times 5. I cannot be looking at 1 over 5 times 25. Okay, we getting it so far? Questions? Okay, now, then the next question is, how do I know that which one is going to be 1? Which one is going to be 5? Must it be the left side must be 1, the right side must be 5? No, right? It's not logical. Because I know 1 times 5 is the same as 5 times 1. Okay? But we can do some deduction. X plus 2y, x minus 2y. Which number should be bigger, which number should be smaller? X plus 2y should be bigger, right? X minus 2y should be smaller, right? Okay? Because x, they are both same numbers. 2y, they are actually same numbers. It is just as good as taking 3 plus 4 versus 3 minus 4. Which one will be bigger? 3 plus 4 confirm bigger, right? So adding two numbers will definitely be a bigger integer. Okay? While x minus 2y will surely be a smaller integer. Okay? So that is the understanding that we can get just from this phrase. Okay? For us to think in this manner. So I can say that, sorry. Okay, I say that since x and y are positive integers, okay, x plus 2y is larger than x minus 2y. Okay? So because we know this already, therefore I can say that x plus 2y, being the larger number, must be 5. And x minus 2y must then be 1. Okay? It was not a random decision for us to jump to this. Okay? There is logical process that leads us to these two equations. Okay? Because when I have two unknowns, two things that I want to find, I must have two equations. Okay? I cannot have only one equation to tell us to find the value. It's not possible for us to solve with just this equation itself. I must have two equations. Okay? For two unknowns. Right? Of course, I can extend it. If I have 100 unknowns, I need at least 100 equations for us to solve. Okay? So, in this case, now that we have it like this, what do you think we should do? Do your simultaneous equation solving. Either you do substitution or you do elimination. Okay? What will you prefer? Elimination or substitution? Elimination. Okay? Actually, elimination is much easier lah. Because x and x, they are really common. Okay? 2y, 2y is also common already. So up to you whether you want to take equation 1 minus equation 2 or equation 1 plus equation 2. That will cause different things to be eliminated. Okay? So what will your preference be? Equation 1 and equation 1. Plus or minus? Joel. Joel. You want to answer or Mary? You're not standing, is it? Huh? Okay. So think Trina looks a bit slower. I lost. Trina, will you do equation 1 plus equation 2 or equation 1 minus equation 2? Plus equation 2, okay, and that will allow you to eliminate what? You want minus. Plus or minus also can one. I just need you to tell me what is being eliminated. So I stick with plus. Is it? To eliminate 2y. Is that what you're trying to say? Yes. Okay, so equation 1 plus equation 2 will help us to eliminate 4y. Right? Because of our working this way. When I open up my brackets, okay, I will see positive 2y minus 2y, that will give us 0. Yes, x equals to 3. Okay, so we sub x equals to 3 into equation 1. Factorisation. Okay? To find two factors of 2491. Is there something wrong? Okay? So find two factors of 2491. Okay? What are factors? They are numbers that multiply each other that will give us 2491. So these are considered factors. Okay? So these are what we are trying to sort of find. Okay? Other than 1 and 2491. So why do they say this is because one very simple factors for any number will always be 1 and the particular number 1. But of course, we don't want this. There are many other combinations. Okay? So they want you to make use of part A for us to know the answer to part B. Okay? We want to know what is this number as a whole. I'm over here, Lucas A. I don't know why you're looking outside. Okay? Focus. Alright? We are trying to find the number as a whole here and the number as a whole over here. Okay? So x squared minus 9, if I let it to be equals to 2491. Alright? I can solve this to find out what is the value of x. Okay? So you will tell us that x squared equals to 2491 plus 9, which is 2500. And I can find that x equals to square root 2500. Am I right? Alright? X squared equals to 2500, so x is equals to square root of 2500. Is there something wrong going outside? Why is everyone's attention outside? Okay? Is this correct? Correct? So our answer x is only to be 50. What's missing? Positive and negative. Okay, do you remember? Alright, positive 50, when I square it, I can get positive 2500. But negative 50, when I square it, it means negative 50 times negative 50, and negative gives us positive. So we should have two solutions of 50, otherwise negative 50. Okay? But that is not all. Was the question asking us to find out the value of x? No. Okay, the question is asking us to find the two factors. X is not a factor. X is just a solution to this equation. I'm making use of part A to solve this. How am I using it? When I say x squared minus 9 is equals to 2491, I can also say that x plus 3 times x minus 3 equals to 2491. Because x squared minus 9 and x plus 3 times x minus 3, they are equal to each other. Right? Say so over here. They are equal. So if I can find out the value of x, okay, I will then be able to know that the factor here and the factor here, what are the two numbers that multiply with each other to give me 2491. So let's say that when x equals to 50, because there's two situations over here, I find that x plus 3 will be equals to 53, and x minus 3 will be equals to 47. Okay, and with this I can say that the two factors are 53 and 47. Because when 53 multiplied with 47, it does give me 2491. Okay, let's get this. No. Okay? Alright. Of course, there's also another case that you can have, but the question is only asking for two factors. This is two of them, which is enough already. Okay? If you want to consider x equals to negative 50, you can just that x plus 3 will be negative 47, and x minus 3 will be negative 53. Okay? Then with this, we say that the two factors will be negative. Okay? So, two factors will be negative 47 and negative 53. So this can be one set of solution. This is one set of solution of this one as well. Okay, you just have to give me one of the sets you are looking for, since you're only looking for two factors. Okay? Questions? Alright? I just want to confirm that I have given this set of questions as homework for exercise 4B. 1A, E, 2A, D, 3C, 4A, 6, 8B,